Okay, well, welcome and thank you for having me here to talk about gateways this evening. So let's see if this clicker thing they gave me works. There we go. That's the name. I think we know that. So Intel has a platform too, in case you didn't know. The platform really is kind of the end-to-end architecture, right? So that includes everything that runs in the data center and on the edge, right? But tonight I want to talk a little bit about the gateway. That's that green box that you see there with a little wireless icon coming off of it. I'm actually in the gateway team, so I work directly with a number of the folks in the larger platform space, but I just want to talk a little bit about the gateway tonight. So to me, the gateway is a little bit of an overloaded term. So if you look it up in the dictionary, it doesn't say anything about IoT, but the gateway that we think about has to do with that piece of hardware that lives on the edge that sensors are connected to, that talks to dumb sensors and smart sensors, aggregates and normalizes that data, and sends it up to the cloud. It also can take control input coming back from the cloud. So, but from our perspective, there needs to be a little bit more. You need to have some of that pre-integrated and pre-validated hardware along with software. And there's also a few other critical elements of a gateway that go beyond just the hardware and what you would think of as the application layer running on top of it. So from the silicon perspective, we want to make sure that we're providing gateways that scale. Right, so that's why you see both Quark all the way through Core. Right now we have gateways that run on Quark, Atom, and now Core. And the idea here is to be able to take something off the shelf, add it to something in the brownfield, and make it connected. And we see that something like 85% of the systems that are out in the field today aren't connected. So the elements of a gateway there need to be a number of critical elements. And I remember probably 7 or 8 years ago when a friend of mine who's a maker, he showed me some stuff that had an Arduino hooked up to it. And I was like, wow, that's amazing. You can do all sorts of stuff with it. And he was saying that it allowed him to turn a hardware problem into a software problem. And that really resonated with me. And I would take it a step further, and we want to think about the gateway as that critical element that allows us to digitize the real world. So this lets us take what was once a piece of analog data out of the real world and turn it into something actionable that's digital. And in order to do that, you need to be able to trust that data. That's where security comes in. So that means security about the physical device, as well as the software, data at rest, data in flight. It needs to be able to scale, as we all talk about all the time. And the other really critical component is manageability. If you have thousands of gateways out in the field, you need to be able to manage them easily. Finally, the time to market piece is important. A lot of our customers, they come to us and they say, well, I've been working on this platform, and I've been working on this architecture that's going to run on my gateway, and I've had to take care of all of these different things. I don't want to take care of that stuff anymore. I want to know that somebody is going to be taking care of the security piece of it for me, the manageability piece of it for me, so that I can focus on the value-added components that make me different than my competitors. And that's where we see our role coming in. So the question is, why a smart gateway? Why not just put a whole bunch of smart sensors out there and have them all reporting up to the cloud? And the reason is that data can get expensive. So we're not seeing the cost of bytes being sent over the network come down in relation to how much it costs to store it and how much it costs to send it over, the internet. The problem is, if you're sending every bit of sensor data up to the cloud, then you're going to see unsustainable cost increases. The idea is to be able to take that data, aggregate it, normalize it, and potentially act on it right on the edge. And that's where we see our value coming in. We want to be able to take the processing power that we can provide and give it to you, and put that out on the edge in a secure and a manageable way. So in a traditional software development world, I suppose in IoT there's probably a lot of folks who are in the embedded space. See a show of hands. Who would consider themselves as embedded? Yeah, I see quite a few. Who would consider themselves like more of a traditional desktop software developer or provider? Any idea? Not a whole lot, okay. But what we're seeing from our perspective, when we go to our customers, they'll take their gateway and they'll give it to a couple of recent college grads and say, okay, do something with this. And they're going to break out their stuff that they've learned in their computer science classes and try to do it. And it turns out that the embedded space is quite a bit different than your traditional desktop development. So we think of desktop development as being flexible and powerful. You can put any IDE on it. You can install whatever software you want. It's more of the traditional development model. You develop and test and debug your code all on the same device. But if you compare that to the embedded space, these need to be hardened devices. They are often resource limited. They need to be very secure. And they're going to have limited functionality that is based on what application the system is targeted to run. It takes longer to learn, right? It's a steeper learning curve. And if you want to deploy software on the target, often it's a host-target cross-compilation that you need to do, which is a bigger lift for deploying applications if you're used to developing in the traditional space. So we see our value as being able to take the best of both of these worlds, provide a secure, hardened gateway, but also provide an easy development experience. So we're also looking at providing this level of architecture on a number of different operating systems. Now, when I first joined a couple of years ago, this division, we had one operating system, and that was Wind River Linux. And it turns out that if you're not used to developing in the embedded space, and you're not used to paying the premium that comes along with it, in both in cost and the time to learn it, then it can be a steep learning curve. What the market has told us is that there needs to be more choices. So earlier this summer, we announced additional operating system options that will be supported as part of our Intel IoT Gateway portfolio. And currently, those operating systems, in addition to Wind River, are Microsoft's IoT offerings and the Snappy Ubuntu Core. Now, the Snappy Ubuntu Core is what we would consider an open source OS. So that's being offered you would say at the low end of what it costs to turn up an Intel IoT Gateway. And then, of course, Windows 10, Microsoft has begun to deploy out a solution based on Windows 10 that's targeted specifically for IoT. On top of those operating systems will run on top of, right now, a select group of Intel processors. It starts with Quark at the low end, Atom in the mid-range, and now with our most recent version of our Wind River offering, we have a Core processor that allows us to do quite a bit of compute on the edge. I apparently have to click this thing twice. Okay, first let's talk about Microsoft's offering. From their perspective, they want to provide one platform that you can develop upon without really worrying about which OS you're targeting. It needs to be something that you can use a developer that's used to doing typical Windows development to deploy IoT solutions. Anybody who's done drivers on Linux will know that it's not always easy, but the universal driver model allows you to quickly bring up additional peripherals, similar to what we all know in the desktop space. Natural user interface, that's some new stuff that Microsoft is working on, handling gestures and that sort of thing. And then in terms of deployment, that's the pretty typical Microsoft stuff. Bringing enterprise-level security, hardware root of trust like TPM, being able to really lock down the system. This goes to being able to harden a Microsoft-based gateway. And then finally, being able to support lots of different peripherals. And we always talk about Zigbee and Z-Wave and 6LoWPAN and other connectivity options. And then, of course, there's Microsoft Azure cloud services. So keep clicking. So the additions that they have coming out, 3 specific additions that Microsoft is deploying for IoT. And the first is Windows IoT Core, and then there's IoT for mobile, and then there's IoT for industry. The 2 offerings that we're supporting initially are the Core for really lightweight devices or relatively lightweight devices, and then the industry ones, which they call Windows 10 for IoT Enterprise. So we have a code name for the Windows-based gateway that we call Calypso Island. And this is, we've been working very closely with Microsoft to nail down the requirements for what we would call an Intel IoT gateway running on Windows 10. And this brings everything that you're used to from Microsoft: Windows updates, Visual Studio for development, additional new user interfaces that are things that you might have heard about, like HoloLens, security, integrated connectivity using AllJoyn. AllJoyn is Microsoft is a member of AllJoyn for normalizing data, and then there's the Azure cloud. So in terms of what we're supporting today on Microsoft is we have a number of existing IoT gateway designs that will support Windows 10, mostly enterprise, right? This is essentially it's a desktop operation, desktop OS that has been modified for running as an IoT OS. Going forward, we're bringing in Atom support, which is kind of a mid-range, low-power processor. And then we're actually working on a reference design board that is in the sub-$100 range that has Wi-Fi and Atom processor on it that we are calling Falcon Beach. And that's targeted for market release in Q1 of 16. So we're seeing a lot of pressure, I think, both competitively and from our customers to bring the cost of these systems down while still providing the level of compute that the market wants. So that's the story on Microsoft's side. Now, on the other side of the story is Ubuntu, right? Most people know about Ubuntu. They use it it's a very common desktop operating system for Linux users. But this offering is not just taking Ubuntu and dropping it on an IoT device. This is Ubuntu's Snappy Core, which is essentially a very stripped-down version of the Ubuntu OS that's targeted specifically for secure, lightweight deployments. And I could talk about that a little bit. And there's plenty of more information about Snappy on Ubuntu's website. But what it does is it allows for faster deployments, more secure. It's the operating system itself is read-only, and you need to be able to put your application on top of it that runs in a very secure container. Transactionally updated, that means that an operation must succeed or as if it never happened, right? If it doesn't succeed, you need to go back to the state in which you started. So in terms of transactions, that it's like going to the cash register when you're buying something. You either complete the transaction or you leave the store without anything, and they don't keep your money, and you don't keep the thing if that transaction doesn't actually complete end to end. So the philosophy here is to make sure that whether it's data being pulled down or data being pushed to the gateway, whether it's a firmware or an OS update, these are all transactional in the Snappy world. Anybody who's used to deploying RPMs or Debian packages knows that it's not always the easiest thing to handle all your dependencies and deal with every potential configuration that might be out there. The Snappy system has a different deployment and packaging system they call snaps, and it's much more simple to deploy. So the architecture itself, you still need, of course, to have your board support package that covers all of your peripherals and everything down at the low end. But then you have the Ubuntu Snappy Ubuntu Core running on top of that, and then you have these additional frameworks that folks work with Ubuntu to deploy. And once you have all of those pieces in place, then it's very easy to drop what Ubuntu calls a snap on top of it. So those snaps are provided by pretty much anyone, and anybody can turn up a snap store, and you just point a Snappy device to that store, and you can pull down additional snaps. We can talk about the developer experience a little bit. Like I said before, it's really quite a bit simpler than traditional packaging. You put everything in a directory, you have a descriptor file, and you wrap it up. So you have to have all your dependencies in one place, but you know that the software that you put out there is what's going to be on the device. You're not necessarily depending on your package manager to resolve dependencies. So again, if you want to know more about what it takes to build snaps, I think that it's going to be a pretty popular thing. You can visit the developer site on ubuntu.com. So one thing about the frameworks, there will be more frameworks out there, but right now Ubuntu is really only supporting Docker at the moment. But you can think of this as being, if you're used to doing Docker deployments in the cloud, then you can think of this as being a way to extend those deployments to the edge at a very low cost. So everything is containerized, but the framework allows for somebody to work with Canonical. Canonical is, of course, the company behind Ubuntu. You can work with Canonical to create new frameworks that provide exceptions to the security containment that happens as part of Snappy. So more frameworks are coming, as you can see here. So now on to the Wind River stuff. This is the OS that our division has largely been working with, and you can think about from Intel's perspective, when we're going to deploy an IoT solution, we wanted to use essentially the portfolio of products that we have under our umbrella already, and that includes Wind River and McAfee, now called Intel Security. So the idea was to take the best of all of those things, roll it up, and package it as a solution for IoT gateways. So the architecture looks something like this. You have a board support package similar to what we just talked about for Snappy Ubuntu that supports Quark, Atom, and Core processors. You have your Wind, on the right there, you see the Wind River development environment that you can use to deploy basically everything you see here. And then the main pillars of what we talk about as being a gateway. Again, the Wind River Linux 7 is actually running on, we're just releasing these. Anything that's in yellow here was just released earlier this month. The Wind River Linux 7, which runs on a 3.14 kernel, which might seem a little older, but this has to go through an extensive validation process as part of Wind River's validation. And then in terms of connectivity, we want to be able to provide basic out-of-the-box connectivity for lots of different protocols, both connecting up to the cloud and to sensors. So whether it's in a smart building, smart home, doing things like Zigbee, Modbus, BACnet. If you want to do basic pub-sub stuff using MQTT, that's there. 6LoWPAN. If you want to talk to serial devices, we want to make sure that we have all of those connectivity pieces there ready for you out of the box. In terms of security, we want to provide a validated collection of security components that allow you to secure your solution both from the hardware all the way up to the software. So doing things like discrete TPM and secure boot to make sure that you can't boot up a system on the wrong OS. Doing things like signing packages, role-based access control with GR security. McAfee embedded control allows you to whitelist specific applications that are running on the gateway so that only what you want to run will run. And implementing it is actually very straightforward. And then in terms of data security, a lot of the things that are already out there in the Linux world, most recently we were able to, it was pretty cool to be able to boot up a gateway and provision it using an Active Directory ecosystem. So that's new using Kerberos. And finally, on the manageability side, Wind River provides what they call the Helix device cloud, and there's an agent running on the gateway to allow you to manage lots of gateways in the field, everything from software updates to firmware updates and so on. Other manageability options that are often industry specific have to do, things that you might recognize like OMADM or TR69. But you can also configure our gateways just as if they were a home router using a web config. That's what's called Lucy in our new version. The runtime environments, we want to make it easy to deploy software, so we provide things out of the box like Lua, Java, JDKs. I think right now our default is OpenJDK 1.7. But you can deploy Oracle Java and other Java frameworks as well, OSGI, Python, and then you can also extend it with things like Node.js, Mono, depending on what your language of preference is. So we want to be able to provide this base system that you can layer on top your application. There we go. Then we'll have the ecosystem of apps and services that our system integrators and our customers are deploying. So if you look at this, if you think about it, even these connectivity, security, manageability, and what's going to run on the gateway, that's common across all of the OSs that we've talked about. They're the most critical pieces of what we would consider a gateway. So okay, so I talked about the Helix offering a little bit, but it's pretty cool. I saw a demo of a developer who was developing C++ application on his machine, or essentially in the cloud, He was connecting via the web to the cloud, doing code with full syntax highlighting and all of that fun stuff, and actually running a debugger on a gateway that was somewhere else in the world. That was pretty cool to see. So to be able to do development and cross-debugging both in the cloud and on a physical device over, say, a TCP/IP network, which is pretty powerful. It's one thing to develop on a gateway that's next to you and connecting sensors and everything. It's another thing to actually go into the field and develop and essentially develop on that gateway and test on that gateway when you're on a train or on the side of a windmill or something like that. So we want to be able to provide a full development environment in the cloud, and that's what the Helix App Cloud provides, in addition to the Helix Device Cloud providing the full manageability capabilities. We're also, the best way I can say this, the feedback that we got from customers was that our usability could use a little bit of work. So what we wanted to do was provide a system where you could get a gateway out of the box, boot it up, and be able to install the software that you need to develop and deploy in your specific industry. And so what we've just released in beta to some select folks is an application repository that is specific to IoT gateways. It's located at download.01.org/IoT Gateway. It only has a few packages on it currently, but we want to get feedback from our customers in the industry about what other packages need to be up here. Right now we have things like Node, and there's also a visual wiring thing from IBM called Node Red, which is a lot of fun to play with. It's you can essentially do out-of-the-box wiring up, similar to what we've seen with other gateways during this conference, but it's fun to do. And then there's under the hood of that, the gateway package manager is called Smart, so you can essentially just install any of the packages very easily right from the device without having to do any cross-compilation or that sort of thing. So in terms of prototyping, we've also been able to provide a build that has all of the typical development tools that you would expect to have on a Linux-based development, like Make, GCC, etc., right on the gateway. So if you're working at developing your application, if you want to pull down some code from Git and install it, and this might seem like an obvious thing, but that's typically has been something that's been reserved to like a host-based system that you're using as your desktop. So even on it's a little bit slower, but you can actually do your typical configure, make, install on a Quark system right on the gateway, which is pretty exciting to be able to do. So in terms of trying to make it easier to get started, kind of a 10-minute out-of-the-box experience with an Intel gateway, we have the commercial developer kit. So this is an Intel Galileo board, which is a Quark-based processor that comes with a bunch of sensors and a 6-month Wind River IDP Pro license that allows you to experience the full development environment that together Wind River and Intel are providing in a really quick out-of-the-box experience. So it lets you get more familiar with the Intel gateway really quickly. So what ODMs are we working with to provide gateways? As you may know, we don't really build the hardware end-to-end. We provide the silicon, and we work with our industry leaders to actually create these gateways. And one example is Dell recently launched an IoT gateway that actually runs, they support Snappy and Wind River, as well as Windows, just the ones I've talked about. And then other folks like Advantech and Eurotech and so on. So a lot of our partners, they provide industry-specific gateways, but if you were, say, to come to us and say, hey, I want to build a system using your gateway infrastructure, how do I do it? A lot of times what we would do is we would partner you up with one of our ODMs, and we could work together to deploy a specific system for your industry or for your solution. Or it may be that you have a menu of ODM gateways to choose from. I think there are something like 50 different systems out there today that are qualified as Intel IoT gateways. So we're excited to work with all of these ODMs as well as additional OEMs and systems integrators to deploy our gateway solutions. So to summarize, we see the Intel Gateway as the keystone, the piece that is really missing, that piece of hardware on the edge that's part of that seamless end-to-end IoT platform. And we want to provide some choice. That is Wind River, Snappy Ubuntu, and Windows. And then overall, what we really are trying to accomplish is accelerate your development. Is you can trust that we have a secure platform that is easily manageable and that you can quickly deploy your application on to get to market more quickly. And then if you want to get started, you can just go to intel.com/gateways or intel.com/IoT Gateways. I think there's a bunch of aliases there. So if you type intel.com/gateway something, I'm sure it'll point to the right page. So that lets you get started quickly using the Intel IoT Gateways. So that's pretty much what I have for this evening. Thank you again for letting me give you a little bit of background on what we're working on gateways. And I look forward to hearing all of the really great solutions that the industry is coming up with running on our gateways. I appreciate it.